So this whole unit is about solving equations. We're going to start out real slow with just one-step equations. When we solve equations with equal signs and variables, our ultimate goal always is to isolate the variable. In order to isolate the variable, we use what is called inverse operations. Inverse is just a fancy way of saying opposite. And when I say inverse operations, essentially what I'm referring to is backwards GEMDAS. AKA Sad Meg. Okay, so when we are solving for a variable like x, we're going to go in the opposite order of what we usually do. We do addition and subtraction, then multiplication and division, then exponents, then the grouping symbols. Any questions on that? Okay. We have 4 properties. These are not properties that you need to know the names of, just to understand how they work. So essentially what we're going to be doing is moving a bunch of stuff around. And the reason we can do that is because of this property of equality. So the first one, the addition property of equality, says that you can add the same number on both sides of an equation and maintain equality, maintain the truthfulness of that equation. Okay, the important part is that we are doing it to both sides. So if we are moving stuff on the left side of an equal sign, we also need to be moving stuff on the right side of the equal sign. Same thing. And it's the same thing for all of our different operations. For subtraction, we know we can subtract the same number from both sides of an equation and maintain equality. For multiplication, we can multiply both sides of an equation by the same number and maintain equality. And then lastly, this is supposed to say division here. We can, that's too many S's. Division. You can divide both sides of an equation by the same number and maintain equality. As long as we are doing to one side as we are doing to the other side, we're good to go. Okay, so what does this look like in practice? We have most definitely seen this stuff before, I'm going to assume. So if I look at the equation in letter A, how I always do it is I draw like a railroad track down the middle. So through my equal sign, I draw a line. That lets me know anything I do to that left side, I also have to do to the right side. My goal is to isolate this x right here. So in order to do that, what I'm going to do is an inverse operation. So if I have a minus 5, what's the opposite of subtraction? Yeah, so I'm going to add 5. Again, what I do to one side, I'm also doing to the other side. So make sure you don't forget that. Well, minus 5 and plus 5 cancels out. All I'm left with is x, and then 20 plus 5 gives me 25. So that should be my answer. If you want, you can double check by plugging it back in. So 25 minus 5 equals 20. That sounds about right to me. Questions? We're going to do the same thing for all of these. So for letter B, draw that railroad track down the middle. What I do to one side, I have to do to the other. Here is my variable. It's m plus 10. What's the opposite of plus 10? Read. Thank you. Minus 10. So that cancels out on the right side. On the left side, I have 16 minus 10, which is 6, equals m. And we can always double check it if I want to. That looks pretty good to me. All right, letter C. Draw my railroad track through the center. I have 33 equals t over negative 3. What operation is that right there? It's division. So how do I undo division? Read. Multiplication. Do not forget to multiply by the negative 3. Okay, I want to see that negative when we do our multiplication. As I'm saying it, I totally forgot to write it. There we go. We're multiplying by -3 on both sides. So times -3 times -3. That's going to cancel, leaving me with just t. And then 33 times -3, -99. If we want to, we can check. -99 divided by -3 is 33. That looks good to me. Any questions on this page? All right. Things are going to get a little bit trickier. Just a slightly bit. In letter D, again, I'm going to start by drawing my little railroad track. Here is the variable I'm trying to isolate, k. What is that -3.2 doing to k? What is the -3.2 doing to the k, Jacob? It's multiplying, so how do I undo that? I'm going to divide both sides by -3.2. So remember that cancels out on the left side. I got k equals, what does that equal? Anybody? It's a negative something. Ashton? 14? Is it really? There's no way. That's not an even number. 14.25, that sounds better. And again, we can plug it in and double check if we want to. Questions there? Okay. Things get a little hairy when we start talking about fractions. We're not going to panic. It's going to be okay. Draw your line through the middle. X is what I'm isolating. What's going on to that x right now? It's being multiplied by the 4 over 5, right? Do we remember how we undo this fraction? I'm going to have to do the opposite of multiplication, which is, okay, and I'm dividing by a fraction, so that means, Layla, we're going to multiply by the reciprocal. Let me break it down in steps here. I know to get rid of times 4/5, I'm going to divide by 4/5. I know that. It's going to go away on that side. I got x left. But 8 divided by 4/5, I don't exactly know how to do that. So I'm going to write the whole thing out. What is 8 as a fraction? Perfect. Divided by 4/5. And then just like Layla just told me, I have to multiply by that reciprocal. Remember, keep, change, flip. I'm going to keep my first fraction the same. I'm going to multiply, so change my sign to multiplication. And then I'm going to flip that second fraction. I saw a couple issues with this on the test. We're trying to multiply in an X shape. Make sure when we're multiplying fractions, we're multiplying the tops together and the bottoms together, not in an X shape. So if I do 40 over 4, I get x equals 10. Does that sound about right? Fantastic. Any questions on that? I'm going to do it one more time because I know it gets a little bit tricky here with the fractions. Letter F. Draw my line. Here's my variable. That's what I'm trying to get by itself. I know that I am dividing by this -1/3 because it's currently being multiplied to the p. So it cancels out on the right side. And on the left side, I got to think about it a little bit. I'm going to keep my first number the same. That first number is -10. I'm going to write it as a fraction, -10 over 1. I'm going to change the sign from division to multiplication. And then I'm going to flip that fraction upside down. So instead of -1 over 3, I'm going to have -3 over 1. It does not matter where that minus sign goes, by the way. It can go in the top or the bottom. And then simplify. Multiply the tops, +30. Multiply the bottoms, +1. That's just 30. Questions on this? Okay. There's 3 3 examples here. Go ahead and try them on your own, and then I'm going to want volunteers, somebody to write on the little surface over here. It's fun, I promise. They had a blast last class. Work on them first, and then if you got it, volunteer. You got it? Okay. I think so. You got pinch with your fingers and then right. Use 2 fingers if you want to zoom in.
Oh, I want to do this.
You got a problem, right?
Oh, yeah. You know it. Yeah, you're all right. Yeah. Never mind that. What? I might go.
Amazing. All right, who's got letter B? What's 9 times 8? Don't you got a calculator in front of you? Oh, yeah. Oh.
You built like a right triangle. Yeah. I don't know. I just said it. And I keep trying to all 3 angles measure less than 90%.
You can erase the back of the pen too.
Oh. Need to get one of these things.
I know, they're nice. Beautiful. All right, who's got letter C? Autumn was first, sorry. Perfect. Oh, love it. Did we see what she did with that simplifying? Fun little simplifying trick. Let's go over that one really fast because I like it. I didn't even teach her this. She's just that good. If I have a fraction, 2 fractions multiplied together like this, and I have stuff like diagonal from one another that has like a GCF, something that I can take out of both things. So for example, 12 and 3, I can take a 3 out of both of those. I'm going to do it. 3 divided by 3 becomes 1. 12 divided by 3 becomes 4. And now I have a little bit of a simpler fraction to multiply together. 16 over 1. You do not have to use that trick. It's just a fun little simplifying trick. Perfect. Any questions on these guys? All right. So, example 3. Define a variable, then write and solve an equation for the following scenario. Word problems. We got to make sure we're following directions. The number one thing I see us forget all the time is this define a variable part. So let's read this thing. You receive a $30 Netflix gift card for your birthday. The gift card can be used for monthly plans. The basic plan costs $7.99 per month. How many months can you pay for using the gift card? What is the variable here? What is the thing that we don't know? Jacob. Perfect. So let's pick a letter. I'm going to pick M for number of months. And then let me give you some pointers for how we break down these word problems. Number 1 that I'm looking for is a total. Do we see a total number in this word problem? Layla? The 30. Perfect. I know I have $30 to spend. So something like that, a total, is going to go on one side of my equal sign. What else do I see? Do I see some of those math words that we learned in the first unit that tell me what kind of operation I'm doing? What do we think? Yeah, that word per tells me I'm doing some kind of multiplication. $7.99 per month means I'm going to do $7.99 times months, which is M. So that's my setup. Just like I did before, I'm going to go ahead and simplify this, draw my line down the middle, and isolate M. I'm going to be doing the opposite of multiplication, which is division, of course. So 30 divided by 7.99, what is that? Jay? 3.75. Something like that, I believe you. Okay, so like how many months can I actually afford? 3.75? 4 months? What do I think? Why isn't it 3.75 months? Because you what? Oh my gosh. Why, Branson? Yeah, Netflix won't let you pay for 3/4 of a month. We also can't round up to 4 months because we just can't afford it. So 3 months is where we're sitting. Be careful with problems like that.